Hello everyone, this is forecaster Jack Sillin with the synopsis for Sunday, April 29th. So we're going to take a quick look at the forecast, what to expect across the US and why. A look at our GOES East water vapor satellite imagery this morning shows two upper level lows across the northern tier of the country. Each will bring some unsettled weather, but neither will bring any major impacts today. This eastern upper level low moving southeast across parts of the mid-Atlantic will bring some rain and snow showers to parts of New England and New York. No major impacts are expected there, although some snow accumulation is possible in the higher terrain of the Adirondacks, Catskills, and some of the New England mountains as well. The western upper level low, which is across Oregon this morning, will be moving slowly to the south and east today, and we're going to expect some severe thunderstorm activity across the kind of eastern fringe of this system. We'll be looking to parts of western Texas and eastern New Mexico, as well as parts of southeastern Montana, northeastern Wyoming, and western parts of the Dakotas for some severe thunderstorm activity as well. Although there won't, that severe thunderstorm activity isn't expected to be widespread or particularly impactful. We will be looking for a much more impactful severe weather event over the course of the coming week across parts of the plains. I will have a separate video on that later today. So we're going to take a quick look at our ECMWF's overview map. Again, two regions of unsettled weather expected today. Some rain and mountain snow across parts of the Rockies and Pacific Northwest. Again, we're going to watch for some of that thunderstorm activity in this area here and as well down in this area here. And then those rain and snow showers, again, pretty minor impacts from this system. Some of these storms could be strong to severe today, and there's a reason for that. That reason can be explained with this map right here. So as we see thunderstorms develop kind of in western Texas, eastern New Mexico here, as well as that area of the high plains here, those thunderstorms are going to be transporting moisture from the lower atmosphere up through the atmosphere towards the top. And as it does, as the moisture, that warm moist air rises, it's going to cool and condense into raindrops. So that's how we get our raindrops from thunderstorms, or from any precipitation for that matter. And as those raindrops begin to fall back down to earth through this very dry mid-level atmosphere, relative humidities here at about 10,000 feet, 30% across the high plains, only slightly higher down here in Texas, maybe 40 or 50%. Again, that's pretty dry air. So as those raindrops fall through this dry air, they're going to evaporate. And as they evaporate, they turn from liquid raindrops into the gaseous form of water, which is water vapor. Now, a little bit of chemistry will explain why that is a problem for severe weather. So as the liquid water droplets, again, liquid being the medium energy state of the water, as those liquid water droplets evaporate and become water vapor, they gain energy. So it takes a gain in energy for the liquid water droplets to turn into gaseous water vapor. And that energy has to come from somewhere. Where does it come from? It comes from the surrounding environment, so the air around it. And as the energy leaves the air and goes into these water droplets, the air loses energy. And what happens when air loses energy? Well, the temperature goes down. So basically you get this what's called evaporational cooling to happen in these thunderstorm cores. And cold air is much denser than warm air. So what happens is as this air cools, it becomes heavy. And eventually it's too heavy to be supported by the thunderstorm updraft, so it falls down to the ground. And once it hits the ground, it spreads out. And so it's that spreading out that will generate very strong winds associated with some of these thunderstorms as they move through their life cycle and kind of ingest that mid-level dry air, which will contribute to the evaporational cooling and then that downward motion. And so, again, damaging winds are going to be the main threat from these storms due to that process that I just described. Thankfully, the storms aren't expected to be particularly widespread. Take a quick look at our thunderstorm composite map, which kind of gives you an overview of the ingredients we need for severe weather. So the shading is instability in terms of CAPE, convective available potential energy. You can see we're looking at only about 250 joules per kilogram of CAPE. That's very low. So only supportive of kind of scattered thunderstorms. A little bit higher here across the high plains. Wind shear, if you look at the green and blue vectors, that's kind of our measure of wind shear, so mid to upper level winds. There's some decent wind shear here across the high plains, not nearly as much down in Texas. So again, that's going to be another mitigating factor. And then our trigger mechanism, there's a frontal boundary kind of surface low pressure system here, and a more subtle wind shift boundary here in Texas. So again, not a big severe weather day, but do expect some storms. If we take a quick look at our weather models, kind of simulated radar is what this is called, so kind of an idea of what the radar might look like this evening. You can see again some severe thunderstorm or strong to severe thunderstorm activity up here in the area that we were looking at, kind of northeastern Wyoming, southeastern Montana. That will move eastward into parts of the Dakotas later in the evening. And then some more activity again down here in the western Texas, eastern New Mexico area. So those are kind of our two areas to watch for severe thunderstorm activity today. Elsewhere across the country, relatively quiet. I will have another update later today about the much more widespread severe weather activity forecast across portions of the plains Tuesday into Wednesday. So stay tuned for that. Thanks for watching.